Ever remember looking outside your window on a snowy December day? You woke up and walked outside to realize that there was water dripping on the gutters. Then you look up to realize it was from the icicles that were starting to form on the gutters. Later, you go inside and check the weather and notice the temperature has dropped 5 degrees below freezing. Since the temperature has dropped, this causes freezing as energy is taken away and the water freezes. When the water freezes on the gutters, it turns into icicles. The macroscopic view is the icicle. If something is at the macroscopic level, this means that you can actually see it. For the liquid on the gutter to turn into a solid, the liquid molecules first have an arrangement of molecules close together sliding past each other. After that, energy is taken out so the molecules end up changing into solid molecules which are tightly held together in place and vibrating. Since energy is being removed when the water is freezing to become an icicle, this is an exothermic process. And once the liquid becomes solid, intermolecular forces form and become stronger. Exothermic means energy is going out. This process causes the particles to transfer heat, which is also called conduction. After another 2 hours, the sun comes up and it is suddenly a little warmer. In order for the icicle to start melting, the particles must collide with each other in order to gain the energy necessary to be in the liquid phase. In solids, the molecules are very close together, so it's easier for them to transfer energy to each other. For melting to occur, there must be a source of heat which will cause collisions between molecules. As they continue to collide, the temperature will get warmer until the ice finally melts into liquid water. The water particles are gaining their energy because energy from the sun is transferred through space, through Earth's atmosphere to Earth's surface. This means that the reason the icicle is melting is because the atmosphere around it is warming the particles and giving them energy. As it continues to get hotter, the melted water is gaining energy and is turning into water vapor. This process is called evaporation. The outcome of this is the liquid turns to a gas and the molecules are now spaced out and moving freely. After the water undergoes this process, it is now water vapor. This is a microscopic view of an icicle in all 3 phase changes. Since the icicle is a solid, the particles are very close together and vibrate. When the icicles were melting and turned into water, the particles are able to move freely and have no arrangement. Then, when the icicle was evaporating and turned into water vapor, the particles are very spaced out. A conductor is a transfer of heat while particles are colliding. When the icicle melted and became water, it wasn't as good as a conductor as when the icicle was frozen because a solid's molecular structure is compacted and the molecules can easily collide with each other in order to transfer energy to each other. Although the liquid in this case isn't as good of a conductor as the actual icicle, it is still effective because particles are also close together and transfer a little energy. When the water melted and turned into water vapor, the molecules were so spaced out, the transfer of energy was very weak. This resulted in less collisions between molecules, which meant the water vapor was a bad conductor. Intermolecular forces are forces that keep molecules together. The intermolecular forces in the icicle are very strong because the molecules are compacted together and vibrate in place. While melting and turning into water, the particles are not as strong, which makes the molecules spaced out and allows them to slide past each other. During the process of evaporation, when the water turns into water vapor, the particles are very weak, which causes them to be very spaced out and as a result are able to move freely. The difference between a physical and chemical change is during physical changes, substances change but the composition doesn't. For example, the temperature is changing when the icicle melts and as a result cause a change in substance without changing the makeup of the icicle. During a chemical change, one or more substances become new substances. The icicle going through freezing, melting, and vaporization doesn't go through a chemical change since the substances don't become new substances. At the end of the day, you know what happened to the water on the gutters from the icicles that you saw earlier in the day. The icicle went through freezing, melting, and evaporation all in a matter of a couple hours. This goes to show that phase changes are occurring in our lives every day, even though we may not realize it. Next time you look outside your window and notice icicles forming, remember the chemistry behind it.